There. I went through and made you guys some examples of some work to hopefully help you out with this pool project that you're going to be starting on today. I went ahead and did all the work. I'm just going to go through it and explain it. What we're using here is a cylinder, and I've already labeled it as 2 feet by 5 feet. To find the area of a cylinder, hopefully you already found this in Khan Academy, we're going to take the volume is equal to pi times the radius squared times h. This equation came from finding the area of one end of the cylinder, commonly called the base. And then to find volume, we have to have another factor to multiply by the height. Our second step would be to substitute our values in for our radius and our height. Substitute our value in for pi. We're going to use 3.14 in all of our calculations. And when we multiply those across, we come up with a volume of 62 8/10 feet. You'll notice now that it's to the third power because we're talking about a cubic measure. All of our values here, we're going to go ahead and round them to the nearest tenth. This will be posted on Google Classroom, so I'm going to go ahead and move past this. You can rewind and watch again. A cone is very similar to a cylinder. The only difference in their formulas is that the cone's formula is 1/3 the volume of a cylinder. By the same steps, we want to go ahead and substitute our values. Pi is 3.14, radius in this case is 2, height is 5. We use our multiplication to simplify. Something cool about this problem is that we knew that pi times 20 is 62 8/10, so we can just bring it straight down here. Multiply by 1/3 or divide by 3 to find out that the volume is 20 9/10 feet to the third power. A sphere is just a little bit different. A sphere uses the formula where the volume is equal to 4/3 of pi times the radius cubed. The reason for the radius cubed is because we have multiple dimensions here with a sphere that all go the different directions, but the principle is the same, where we substitute our known values, we do our multiplication, and then we get our volume and round it to the nearest tenth. Now, that was a lot. I apologize I'm going so quickly, but thank goodness for the blessing of video. Let's talk about what happens when we're looking at something where we have another cylinder and we're talking about how many gallons of water would fit in this cylinder. Something to know about water versus volume. There's a such thing as dry volume, and then there's wet volume. In this case, we're going to have to find both. To find the dry volume, we do the exact same thing that we did before. In this case, we're looking at the diameter is 16 feet. We're looking at the radius is not the same as the diameter. It's only halfway across, so the radius has to be 8 feet. And we have a height of 4 feet. Understanding these pieces to it, we can go ahead and apply what we did in the previous examples of substitution and then multiplication until we find that our volume, our dry volume, is 803 9/10 feet cubed. I keep bringing up the dry volume because there's a big difference between dry volume and wet volume, and here's where it is. When we're talking about a wet volume, we're talking about every single cubic foot of space is equal to 7 and 4,800 gallons of water. That's 7.5 gallons of water for every cubic foot of space. What that means is if we want to find out how much water fit inside of this cylinder, we're going to have to take an equation where we look at the total volume in gallons, or the total gallons of water is going to be equal to 7 and 4,800 gallons per cubic foot of dry volume. Substitute in what we know from up above, where the volume was 803 9/10 cubic feet. Multiply it out, and what we find out is that that cylinder would actually hold, with those measurements, 16 feet all the way across, 4 feet deep, would hold over 6,000 gallons of water. That's quite a big difference. Something else you're going to be figuring out in here is if you're going to make a pool that's this size that's going to hold 6,000 gallons of water, how are you going to fill it up? You know, most people just have a garden hose, and a lot of those garden hoses are just a 1/2 inch in diameter. Well, if that's the case, then what we need to understand is the flow rate from a garden hose like that is approximately 9 gallons per minute. So we have a little more work to do. What we do with that is we're going to take our total gallons of water that we need and divide it by 9 so that we find out how many minutes it's going to take it fill it up. We're like, oh, okay, 668 minutes. That's not too bad, right? Well, think about that. Let's take our number of minutes and let's divide it by 60. And we find out that using that standard garden hose, it's going to take just over 11 hours to fill up that pool. That's quite a bit. We went from 803 cubic feet of volume to 6,000 gallons of water that would take nearly 11 hours to fill it up. Don't worry, there's a couple other options for a 2-inch hose and a 3-inch hose that you'll also need to find out. But there's also the process that you're going to have to figure out of draining the pool using a couple other different diameter hoses, which have a couple different flow rates. But the principle is still the exact same. Let's say we go ahead and look over here at a volume of a cone and go through the same process. How much water would this cone hold? Well, the first thing we need to do is find the dry volume. Again, our equation, 1/3 of pi times the radius times the height. We recognize that 8 feet is the diameter, not the radius, so make sure we simplify the right value for the radius. Plug it all in. We find out that our volume is just over 100 cubic feet. We can follow the same process of saying, okay, well, if it's just over 100 cubic feet for the dry volume, then the wet volume is going to be 750 gallons. Working through the same process that we did up here above, we would take our total gallons divided by 9 to find out how many minutes, and then divide that value by 60 to find out how many hours. We find out it would take us just over an hour, just about an hour and a half to fill up a cone that's 8 feet wide and 6 feet deep. I really hope this is helpful for you. I'm going to scan these and post them on Google Class, just for those of you that don't have the greatest internet connection like out at my house. And as always, please go ahead and email me any questions that you have. I'll do my best to help you out. I'll continue to put more resources up as I can. But you guys are doing great. I miss seeing you. I hope that you're safe. I hope that you're well. Those of you I haven't heard from, please take some time to reach out to me. I'd like to know that you're okay. Have a great day, guys. Give me your feedback. I'll be looking forward to hearing from you. Take care now.